Good morning, everyone. Good morning. So last time we ended up with the elimination of arbitrary constant for the general solution. So and we are solving to get the differential equation of the given general solution. So now, last time we have a basic equation. Okay. So now we will be solving a exponential functions. So the same rule or the same method, the same process. So in order to know how many how many times that we will differentiate our given equation is by the number of the arbitrary constant. So if you can see here, you have two arbitrary constants, c sub 1 and c sub 2. From here, we are talking with exponential functions. So please recall your differential calculus, the different derivative of e raised to the power of u, which is the derivative number 25. So e to the power of u is equal to e to the power of u. Considering your u is only x, y without any constant. But if you still have a constant like this, like 2, you need to first derive meaning 2x. So let's continue. So from here, you just simply, this is the process. I just write this one, but if you are well versed with differential calculus, you could actually get directly the answer, which is y prime 2c sub 1 e to the power of 2x minus 2c sub 2 e to the power of negative 2x. So let's open a Jamboard so that you, for those others na wala pa kahibaw, so we could show this to you. Ayan, open sa kwa. Okay. So also guys, please be mindful kung ang recording nato ay basin malipat ta pare ganiha. Sige, migstorya wa. Nahuman na yung record na mo. Okay. Okay. So from here, our given is y is equivalent to c sub 1 e to the power of 2x plus c sub 2 e to the power of negative 2x. And we know that we need to derive this one twice. So first, we need to derive this one. But before we derive, be mindful that our e raised to the power of u and our u is 2x. So your u is 2x. And for the other one, your u is negative 2x. So this one, I'm still discussing this one so that for others na medyo nalimot gamay because taas-taas kayo inyong vacation from the COVID. So hopefully you can still refresh your mind by this. So deriving this one, you will derive this one 2x, that is your du will be equivalent to 2dx, while the other one du will be negative 2dx. So obviously, if this has dx here, okay, so ang given is general solution naman, so supposedly kung may derive ta nanay dx. So from here, your y, so when you substitute that one, you have y. So derive na nato, while prime is equals to, when you derive this one, so you have 2 because you have 2 for the du times your constant c sub 1. Then you have your eu, di ba? You have your 2x is u. When you derive your eu, then that is still eu. Okay? So eu plus, so from here, your du is negative, so therefore you have a negative 2 times c sub 2. Okay, then your u here is negative man, so you have still u. From there, you could have y prime equals 2c sub 1 your u is 2x, so 2x minus 2c sub 2 e raised to the power of negative 2x. Therefore, this is our, so that is our y prime. So the step is here. So you could actually direct this one. So I'm sure you already passed the differential calculus, integral calculus na subject. So I'm sure this is just very easy. You could now directly get the y prime. So in the same manner, so because we know that our arbitrary constant is 2, so and we are still having one differential, so we will get the second one. So we'll do direct na lang ha, di nata mo balik ani. So your u, derive this one. So 2 times 2, you have 4. Then copy c sub 1. Then derive this one because this one is already u, so e2x. Then you have negative, we have negative 2 times negative 2, that is positive 4. Right? You will have positive 4. So you have positive 4. So ipakita lang ako, at least mag-guided mo. Okay? Mag-guided mo. Mag-guided mo. Asa na ako gipakuha. So negative 2 times negative 2, you have positive 4. Copy c sub 2. Then e raised to the power of negative 2x. Therefore, this is your second derivative of your given equation. Now, if you could see this one, we could separate the 4, right? We could separate the 4. So therefore, we could have, you separate the 4, we could have y is equivalent to, so y is equivalent to 4, so times c sub 1 e to the power of 2x plus c sub 2 e to the power of negative 2x. So y double prime. So if you could see, this one is just equal to this one. We just move or combine those common nila, so which is 4. So they are still the same. But by doing this, we could say that y from here, this c sub 1 e to the power of 2x plus c sub 2 e to the power of negative 2x is our given y. Right? Muna siya itong given. So, muna siya. Therefore, we could say that, let's use another pen. Or let's just continue with block. So, therefore, we could say, let's erase this one so that we have space. So, therefore, we could say that, therefore, we could say that your y double prime is equal to your 4 multiplied by the given equation. Our given equation is, this one is equivalent to your y. Okay? So, therefore, we can simplify this further. You have, and equate it to 0. So y double prime minus 4y is equivalent to 0. And we know this is second order, so you have d squared y over dx squared minus 4y will be equivalent to 0. So then your answer will be this one. So if you could see here, we don't have arbitrary constant anymore. So therefore, this is in the form of your differential equation. Okay. Therefore, that is already in a differential equation form. So from the given general solution, general equation or general solution, we convert this one in order to know what is that differential equation. Okay? So, again, question. Before I proceed with the next example. Question, guys. So, if you could see here, let me question myself. Okay, for those na di ka question. Sir, sa first example lagi, sir, sige tag-substitute. Why? So, the first example na to, we do substitution because after our third, okay, how many variables? 3 variables. So, after the third in differentiation, we still have an arbitrary constant. In this case, after 2 differentiation, we still have the constant, but the constant could be equated from the given. So, therefore, those constants can be substituted with a variable that doesn't contain a arbitrary constant. While here, the given is totally different with the differentials. Okay? So therefore, in order to eliminate the constant, we need to substitute until we arrive with a general differential equation without an arbitrary constant. So, mana ang rule na to, ani. Okay? Question. Guys, question? Carmel, Denny, Ronnie, Honey, John, Clarice, Divine, Dan, Sherlyn, mamay makita na ako sa akong screen god. Prete, Aliza, any question? Ronnie? No, linya si Ronnie. So, okay, sa Galibo, let me check that chat. Sir, mawala akong signal. Okay. So, don't worry kung magali signal, recorded manita na. So, you can view it again. So, galibog ko gamay. Marnie, asa dapit Marnie? Asa dapit ka galibog? Marnie? From where? The entirety of it? Basta kinisiya day, in order for you to understand, you need to understand your past subjects. Okay? So, you need to understand sa first. Asang first? Kining day? Kining first exam? Kining siya? Or katong last topic na to? Asa dapit day? Sa last topic. So, sa kini. So, kining dapita. So, as I've told you, the process will be the same. Bisa pag unsang problem siya. The first thing you will do is to look at the number of arbitrary constant. This is the rule, di ba? Count the number of arbitrary constant. After that, you differentiate. So, pasabot, i-derive din mo na siya. Differential calculus. So, after derive din mo na siya, kwintaha pila ka constant. I-derive na siya. Kay tulo mo na siya, tulok ka beses ni mo siya i-derive. I-derive ni mo una ning given. Tapos, ang answer is y prime. Pagkahuman, i-derive na po na ni mo siya. Ang y prime na himo ang y double prime. Pagkahuman, i-derive na po ni mo pang last kay tulo mga buok ang y double prime. It becomes y triple prime. The result of that, check, is the y triple prime still has a constant? The answer is yes. There's still a. But, our a here is not equal to any given, di ba? We cannot put 6y because here A is not equal to ax squared plus bx. So, dili man siya equivalent.